Alright, for those of you that were having trouble with the total area, I want to do one really simple problem for you to show you the steps that we didn't get to go through in class. So here's the function. I want to find the total area bounded between the curve and the x-axis over the interval from -5 to 8. That's x values. So remember, the first step we were going to do was find the x-intercepts. And if you look here, the x-intercepts, this is factorable. And I would set them equal to 0. So my x-intercepts are 5 and -3. Second thing I asked you to do was a sign chart of f of x. So my sign chart would start at -5 and will go until 8. My x values that I'll use are -3 and 5. The f of x values are 0 there. Picking -4, it would be positive here, negative here, positive here. And I did that by using this function, the simplified version of the function. And then the last piece I said was, now you're going to write your integral. So this is the piece that you really want to be careful of. So this is one integral. This is two integrals. This is three integrals. So this total area takes a total of 3 integrals. Equals the first integral, because it's positive. Let's do that in orange. I'm going to do just a positive integral from -5 to -3 of f of x, and just to save a little space, I'm not going to write out the whole entire function. The function would be what's up top right here. And then the minus, I'll do in pink. And because this is a negative, it means that the f of x is below the x-axis. It means the area would be negative. And when I do a total area, I want my area to become positive. So we subtract negative areas. And then remember, we add positive areas. So that'd be 5 to 8. So to do the problem, it would take a little bit of work, and I shouldn't have picked such large values, but we'll do it right here. I have f of x is equal to x squared minus 2x minus 15. So antiderivative will be 1/3 x cubed minus x squared minus 15x. And what makes the total area problems a little bit of a pain is the fact that you're going to need to evaluate this function for -3. You're going to need it for -5. You're going to need it for 5. And you're going to need it for 8. Okay? So I'm just going to write those values down for you real quickly, and then I'll show you how to evaluate the integral itself. Alright, so my total area. So to find the orange integral, I would do f of -3, which over to the right is 27. So I'm just going to put this in, I should actually put it in red. I mean orange. So I'll do it in orange, and I'll put parentheses around it. So I would do f of -3, which is 27, subtract f of -5, which is 25/3. And then in pink, I would subtract f of 5, which is the b value, the top. F of 5 is -175/3, minus f of -3, which is 27. And then in orange, the last one would be f of 8, which is -40/3. And then minus f of 5, which is -175/3. And then when you add that all together, that would be your answer for your total area. Now your total area answer is completely different than the answer to the integral that I'm about to write up here. The integral from -5 to 8 of x squared minus 2x minus 15. That would be the net signed area. So the negative area and the positive areas, we would compare them and essentially do a net. Remember, if you owe $5 but you have $8, your net is $3. Okay? Also, just a reminder, when you're doing your total area by calculator, remember, so for that question, I would find the fnint, which is Math 9. Your y1 function, but remember, for your y1 function, actually let me do it in the right notation, you need the absolute value of y1, which you find in math. Move over to num, and then you'll see the ABS, comma, x, comma, wherever you're finding the area from where to where. And remember, that's the calculator notation. On the test, or on your AP exam, you would write it this way. Okay? Hopefully that helps some of you.